at this point, you have seen videos where the coefficients of a variable are the same, where the coefficients of a variable are opposites, where the coefficients of one of the variables, where one is a multiple of the other. Okay, and what we're going to do now is show you what do you do when there is no relationship between the coefficients, right? So 5 and 6, they're not the same, they're not opposites, and neither is a multiple of the other, and the same thing for 3 and 4. So what do we do in this case? So in this case, what you're going to do is pick either of the variables to work with. So just pick one variable. It doesn't matter whether you use the 5 and 6 or the 4 and the 3, and you're going to flip them. So what do I mean by flip them? All right, I'm going to use the x's because it's always easier to see. And I'm going to say, okay, well, my coefficient for the x here is a 5, and the 6 is at the bottom, so I'm going to put a 6 here, and I'm going to put a 5 here. Okay? And so what happens when I do that is I'm going to distribute that 6 to everything inside of my parentheses. So I'm going to get 30x plus 24y equals 84. And I'm going to do the same thing with the 5. I'm just going to distribute it to everything in that second equation or inside of those parentheses that I created. And I have 30x plus 15y equals 75. Okay, so please don't make the mistake here because we are going to add these equations just like we did in the other videos. Please don't make the mistake of just crossing these out because they are the same. Remember, you're adding the equations. So if I add these two equations where I am right now, it will give me 60x, which does not cancel out the x value, the x variable. So that's not what we want to do. You cannot just cross out. Remember, you're adding the two equations. So what needs to happen is we want one of them to be negative, right? We want them to be opposites of one another. So if one is 30, then the other has to be a negative 30. And so what do we do to make it a negative 30? You're just going to pick one of the equations and you're going to multiply it by a negative 1. So negative 1 times 30 will give me a negative 30 here, which will allow these to cancel out. I didn't touch my top equation, so I'm just going to rewrite it. Okay, and then I'm multiplying my whole bottom equation. So remember, you need this to become a negative 30. We multiplied by negative 1, but we have to multiply the whole equation to keep the equation balanced so that we don't change the equation. Okay, and so we couldn't add the equations here. We actually ended up multiplying by 1. Or by negative 1. But here we're going to be able to add the equations. So when I add them, these 30s will cancel out. Okay, so it ends up giving me 9y equals 9. And remember, you're solving for y, so I'm just going to divide by 9. So y is 1. Okay. And now I want to find the value of x. So once again, I'm going to go back to one of these two equations. You can pick whichever one you want. I always pick the top one. And you're going to substitute the value of y that you have. So we found out that y is 1. So I'm going to substitute 1 in for y. And now I'm just going to solve for x. So I have 5x plus 4 is 14. I'm going to subtract my 4. And I have 5x is 10. And 5 is attached to the x by multiplication, so I'm going to divide. And so x is 2. So remember, your solution to a system is not the x value, it's not the y value, but it's the point that has the x and the y. So my solution here is 2, 1. I'm just going to box my solution. Okay, and just remember, always check your solutions by going into your original equation and substituting the values in. So 5 times 2, 4 times 1, does it equal 14? So I have 10 plus 14 equals 14. I'm sorry, 10 plus 4 is 14, so 14 equals 14. Okay, so it worked for my first equation. Now we need to also make sure that it works for your second equation. So remember, if it's a solution to the system, then when you substitute it in, it should work to both equations. Okay, that's what makes it a solution to your system. It works for both equations. So my x here was 2 and my y was 1. And I have 12 plus 3 is 15. So 15 equals 15. So this point 2, 1 is a solution to my system here because it works for both equations. It gives me a true statement when I substitute the values in.